Hey guys, welcome back to another video lesson. Today we are going to continue talking about area. And we're going to talk about area of circles and then area of portions of circles. So there are two different portions that we talk about, being sectors and segments. We'll get into that in a minute. So let's go over a couple examples. First of all, quick review. You guys already know how to do this. Finding the area of a circle. It's pi r squared. So in my example, I'm given 18 is the diameter of the circle. So my radius would be equal to half of that, which is 9. So to find the area of the circle, I just take pi times r squared, which would be 81 pi as an exact answer. And I can also multiply this out in my calculator, and I would get 254.5 square units. Here's my answer for the area of that circle. Next, I can also find the area of a sector of a circle. The area of a sector of a circle is kind of like if you think about finding the area of a piece of pizza. All right, you are looking for just a portion of the circle, just a little slice of it. A sector is created by the region bounded by two radii and then the arc of a circle, which creates that slice, like a slice of pizza. Now, you determine what portion of the circle that is by the central angle. The portion, the way it's cut off is like that is theta degrees, your degree, out of a total of 360. That gives you the fraction. So let's take a look at an example. The area of my sector is equal to my theta, in this case, the portion that I'm looking at is 100 degrees out of a total of 360 degrees. And I need to take that portion that I'm looking for and multiply it by the full area of the circle, which would be pi times r squared. Radius is given to me as 7. So there are a couple of different ways that I can do this. First of all, if I want an exact answer, then what I am going to do is I am going to take the actual numerical values. I'm going to multiply everything except for pi. So if I take 100 divided by 360 times 7 squared, I get this decimal. I get 13.61 repetant, right? I'm going to convert that into an improper fraction, and I would get my improper fraction is 245/18. Now, initially, I did not multiply pi in. So my actual area would be 245 pi, because that would be in the numerator, over 18. So that is the exact area of that sector that I'm given. If I wanted to find the area of that pink shaded region, that's what it is. If I want a decimal approximation, I just take it and actually multiply out that pi. So I can say 245 pi over 18, or I can say 42.8 square centimeters. Okay, those are my two answers. I've got an exact answer, I've got a decimal approximation. Next, I can also have a segment of a circle. Again, a segment, when you hear that word, generally you think, okay, a line segment. Well, kind of, okay, it's created by a chord of a circle. So the region of a circle that is created by a chord and the arc is the segment of a circle. All right, so we're going to go through two examples here. To determine the actual area of this portion of the circle, you calculate the area of the sector, which is this theta over 360 times pi r squared. So that would be the area if you were looking for the full sector. But that full sector isn't what you're actually looking for. You're actually subtracting away a triangle that's also created. So if I draw in a triangle in here, this 1/2 base times height is like the triangle that I'm subtracting away. So if I highlight these two portions, let's see here, maybe that'll help as well, okay? So I'm going to take this full sector, that's all of this, that's this first portion, okay? And I'm going to subtract away what I don't want, which is this triangle that's in here, I'm going to subtract away that area so I can just get the area of what I want, which is the area of the segment. All right, 2 examples. First one's pretty easy. So my first example is this. I've got the radius of circle O is 6, and I know that since this is a right angle, it is a 90-degree angle. So to find the area of the sector, I take 90 over 360 times the full area of the circle, which would be pi times r squared, which is pi times 6 squared. Okay, so that would be the full area of the sector if I was looking for all that, but I am not. I am just looking for the area of the segment. So I have to subtract away the triangle that is created, 1/2 base times height. Well, this is why this first example is so easy. My base and my height are both created by a radius. So I would subtract 1/2. My base is 6. My height is 6. Okay, so let's simplify this a little bit, all right? So 90 over 360 times 6 squared. It's mental math, I don't need a calculator. 9 pi is the full area of the sector, which is created, and I need to subtract away 1/2 times 6 times 6, so minus 18 is the area of that triangle. So this is my exact area. I would stop right here. I cannot combine those 2 terms because 9 pi is, I'm multiplying 9 times pi, and 18 is just by itself. Those are not like terms. I can't combine them. But what I can do if I want a decimal approximation of this is I can take 9 times pi and then subtract 18 from that, which gives me approximately 10.3 square units. So when your sector is created by a 90-degree angle, it's pretty easy. It's pretty straightforward because you can easily find the area of that triangle that you need to subtract away. All right. So if you look at example 2, this is a little bit more difficult. It's not terrible, but it's fine. So you still need to find the, let's see, I'm going to go down here so I have a little bit of space. You still need to find the area of the full sector. So the area of the full sector is still pretty easy. My radius is 14. Okay, great. So I'm going to take areas equal to 120, which is my central angle, my theta, 120 over 360 times pi r squared. So pi times 14 squared. Now I have to subtract away the area of the triangle. This is where it's a little bit more difficult because I need 1/2 base times height, and I don't know what either of those are. So if I go back into I'm going to focus in a little bit on this triangle here. So this triangle, I do know that each of these sides is 14 because they're each a radius of the circle. Now, if I split this central angle in half, I know that this is perpendicular. That was one of our radii to chord theorem, something. I'm splitting it in half. If I zoom in on that triangle, one of those triangles, what I've actually created is I took 120 degrees and I split it in half to get a 60-degree angle. My hypotenuse is 14 because that was the radius of my circle, and this angle down here is 30 degrees. I have actually created a 30, 60, 90 special right triangle, which we all know and love already. So think about those ratios. My short side is 2 times x, so that means that this short side would be 7, and then this long side would be 7 root 3, which if I label that over here, the height of the triangle is equal to 7, and the base of one of those triangles is 7 root 3. The base of another one of those triangles is also 7 root 3, which means that my B, my base of that triangle, is 14 root 3. Okay, so if I take and fill it into my formula that I've been working with, now I've got 120 over 360 times pi times 14 squared minus 1/2 times base. My base is 7, or my base is 14 root 3. My height is 7, but order doesn't matter in multiplication. So 1/2 times 7 times 14 root 3. Okay, so if I simplify this, I would get, let's do 120 over 360, 14 squared. If I simplify this, this is actually another one of those fractional ones. So I would have my area is equal to 196 pi over 3. Okay, so that would just be the area of the sector minus the area of the triangle, which is 0.5 times 7 times 14 root 3. So minus 49 root 3. So that would be my exact answer. Does it look a little hideous? Maybe, but that's fine. It's exact. I can also now just multiply those things out, just type it in exactly as I see it on my paper here. So 196 pi divided by 3 minus 49 root 3 is what I'm typing into my calculator, and I get 120.4 square units. So that is my final answer for the area of the segment of the circle. All right, that is all that I have for you today. Those 4 examples, 3 areas. Hope you learned something new today. Hope you have a great rest of your day. If you have any questions, as always, email myself, Miss Leverson, or email Mr. Gibbon. We'll talk to you soon. Bye, folks.